Welcome to Tech Diet. Let's dive into our today's problem, maximum value of an ordered triplet 2. It says you are given a zero index integer array nums. Return the maximum value of over all the triplet of indices I, j, k such that I less than j less than k. If all such triplet have negative value, we need to return 0. And the value is governed by nums I minus nums j into nums k. So let's look at our test case. So we need to find the nums I minus nums j. So that means we need to find the maximum whose difference is maximum. And for the difference to be maximum, that means this nums I should be more, nums j should be as least as possible, and nums k should be again more. That will give us the overall maximum value for this whole computation, right? So the first index that we choose should be of higher value. The second index should be choose should be of minimum value. Third index that we choose should be of higher value, and that should be within the order I less than j less than k. So what are the possible values for an I would be like it should always range between nums or length minus 2, the array length minus 2. So we need to choose our I from first three indices. Then whatever our maximum is, so here our maximum is 12. Then in the remaining indices, nums minus 1, the length minus 1, that will be our criteria for J, choosing the J. And here the minimum value for j would be 1, so 12 minus 1 is 11. And then whatever the leftover value of arrays, we'll choose k from that and we'll choose the maximum, so we'll choose 7 here. So 12 minus 1 is 11, 11 into 7 is 77 is our output. Similarly, let's roll it over for this particular case. So here we need to choose the maximum I between these indices. So maximum I here is 10. Then the remaining indices minus 1, we'll choose our j. The minimum is 3, which is gives us 7 as the corresponding difference, and then the maximum is 19, so 19 into 7, which is this 133. Let's roll it over the next test case. So we need to find the maximum I from single input, which is 1, minimum j from single input, which is 2, and then 3. So we return into negative value minus 3. Since it's a negative, we'll just return 0 as our answer. So let's roll it over one different test case. So here again, till this index, we need to find what is the maximum I. So here the maximum I is 19. And then post that index, what is the max minimum j? So which is 8. 19 minus 8 is again 11. 11 into the leftover value is 16. 11 into 16 is 176. So but here our answer would be like, we'll choose this 12, we'll choose this 2, which is 10. 10 into 19 is 190. So we had two choices here, either we choose 19 as the first index, then we choose 8 as the second index, then we choose 16 as the third index, so we'll land into 176. Or we could choose 12 to 19, which gives us better answer 190. So that means clearly I can't just rely on the maximum I, minimum j, maximum k. That will not work in this particular test case. So what I can say is, what let's compute it for each interval, for each difference into the corresponding k, right? So we need to calculate the each difference, what is the maximum difference I can make till this point, and what is the maximum k I had so far. So figuring out maximum k is not that toughy. So what we can do is, because k will be always from the right hand side, so let's try to build our maximum k so far. So we'll have 16 here. What will be the maximum I'll always keep is 16. From 16, 8 will keep 16. 16, 16, 16 will keep 16 here. Then we have 14. We so far maximum I have seen is 16. Then so far maximum I have seen is 19. Then we'll keep on rolling it. 19, 19 for 12 as well, it's 19. For 11 as well, it's 19. For 2 as well, it's 19. For 9 as well, it's 19. Then 7, then 12, 12, 11, and 6. So this will be our maximum array so far that we have from the right hand side. So we need not to compute it till we'll always need to start from the second index. This can left it as empty because that will be our I and j for this particular array. So let's say we have just 3 elements, then it would be like 1 2 3, and third is always 19, the leftover part. Then we'll expand our array. So what is my maximum for this particular given sequence? So my maximum for k value will always start from 2 because I need to find a triplet there. So from 2 till that last of the array, what is the maximum so far that I have seen? So that is our max array. Now we need to compute the max difference so far that I can have. So with just single list I can't have difference. With 6 and 11, the maximum difference satisfying this criteria is I less than j, and nums I should be greater than nums j, which will be, so here my nums I is 6, I don't have anything else, so this is actually ruled out, so we don't need to compute this. From the second index I can say what is my maximum difference. So this, the maximum value is 11, so that will be 0. For 12 again, the maximum is 12 itself, maximum is 12 itself. Now we have 7, so maximum I was 12, 12 minus 7 is 5, then we have this 9, so 12 minus 9 is 3, then we have 12 minus 2 is 10, 12 minus 11 is 1, 12 minus 12 is 0, then 12 minus 4 is 8, then we have 12 minus 19, which is negative, so we'll keep 0 here. Then we'll have 19 as our maximum so far, so we'll have 19 minus 14, which will be 5, then 3, then we'll have 11, then we'll have 4, 3. So this is our max difference array. So now from the second index of this and the third element of this, we'll keep on multiplying. Here we have 0, here we have 0, 5 and 19, 19 and 3, 19 and 10, we get 190 here, 19 and 1 is 19, 19 and 0 is 0. So far we'll compute this array and we'll figure out what is the overall maximum. So we'll land into 190. So let's simulate this situation. We'll have our max array initialized, which will be computing the maximum so far from the right side. So let's just have it till the length of my array, and we'll start it from the length minus 1, I greater than equal to 2, I minus minus. I can say the maximum array here would be the math dot maximum of max so far, and whatever the corresponding element here it has, nums of that type. So we can say this is my maximum element here. Can initialize it to 0 for now, and then in my max array I can substitute the value as the corresponding maximum. So we have formed our this array. Now let's compute the max difference. Nums dot length, so we need to compute it from the ith, the very first index, I less than nums dot length minus 1, I plus plus. So here we need to compute the maximum. Let's say my maximum is equal to whatever the nums of 0 was, and the max diff array will be for that particular ith, what is the difference if this particular I is greater than is less than the maximum. So if it is less than maximum, what I can say, the maximum difference of I would be the max minus nums of I, and here my max could be math dot max of the current index and the number index. So here we have 11 and 6, so our maximum is 11 and it's not less than, or let's make it less than equal to, so we'll have a 0 here. Then we land till 7, our maximum will be 12. 12 minus 7 will be 5, so that should fill up that array. So now we can compute our for int I is equal to 1, I less than nums dot length minus 1, I plus plus. So we can say what is the maximum value of this difference, multiply the max array which is at kth position, the 1 plus index. So my out will be the math dot maximum of max, and this out, let's call it max, and then we can just return out. So that is the overall maximum for each triplet. Okay, let's try to hit submit. Yep, this is accepted. So yep, that was our intuition. We'll form the corresponding max array from right hand side, and to clip of this part nums k, and then we'll find the corresponding difference array, which will be like what is the maximum so far I have seen minus that particular index, so that I can have a triplet of I and j within the bounds such that I is less than j. So that is our computation for max difference. So we'll figure out the maximum of that index and the current maximum, then we'll find okay what is the maximum difference so far, and for each maximum difference what is the max k that I can multiply. So that is the approach. Thank you.